Microprocessor and microcontroller EC403. Today I will discuss the pin description for maximum mode of 8086 microprocessor. In my previous class I have discussed the pin description for minimum mode of 8086 microprocessor as well as the all other functions of different pin of 8086 microprocessor as well as the difference between 8085 microprocessor and 8086 microprocessor. So you remember that, or also I have discussed that pin number 33 is very important here. That will decide that the processor will use for which mode. So when it is 1, so that means the minimum mode. When it is 0, so the maximum mode. In minimum mode, in 8086 microprocessor uses as single processor, and in maximum mode it is used as the multiprocessor. So in minimum mode, already I discussed the pin number 24 to 31 have the unique different functions, and for maximum mode the functions of pin number 24 to 31 is QS1, QS0, S0 bar, S1 bar, S2 bar, log bar, as well as the request grant 1 and request grant 0. So you try to understand the different functions of these pins. So actually the QS1 and QS0, okay, so these two actually the instruction queue status, instruction queue status, instruction status. Okay, so these actually the status signal. So that means the whatever the operations happen in the instruction queue, so accordingly these the QS1 and QS0 will show the status. Means QS1 and QS0 0-0 combination, 0-1 combination, 1-0 combination as well as 1-1 combination. 0-0 it show the no operation, and 0-1 is the first byte of opcode from queue. 1-0 empty the queue, as well as 1-1 for subsequent byte from queue. Okay, so first you try to understand the what is queue. So queue is the first in first out register set. What is queue? This is the first in first out register set. So actually in 8085 microprocessor and 8086 microprocessor, these are the another difference, that in 8086 internal architecture the one queue, that is a 6-byte instruction queue is present, where actually the instructions are stored. Means 6-byte 1 2 3 4 5 6 1 2 3 4 5 6, and this the width is the 8-bit. So that means 1 byte, 2 byte, 3 byte, 4 byte, 5 and 6 byte. So 6-byte instruction queue. So in internal architecture, when I explain, so this time you will understood properly. Just you remember that here actually the, if you consider the one instruction in 3 byte, so first here it will enter first opcode, okay, then the next operand will enter or the address will enter. So this time the opcode will pass where, here and here, and accordingly, and after that the next instruction will enter. So this time the first instructions will enter where, here, and the next instruction will enter, and accordingly So when the third instruction will enter, so this time your first instruction will out from the queue and that will execute. Means this concept is actually called the pipelining concept. This is a special feature of 8086 microprocessor. You remember this? So actually, whatever the operation happen here, accordingly the QS1 and QS0 will be show the status. When no operation 00, when first byte of the opcode from Q, first byte of opcode from Q, so this time 0110 empty the queue and 11 for subsequent byte from Q. Okay. So when I will discuss the internal architecture, so this time you will understood properly. Now the pin number 24, 25 you understood. Now the 26, 27, 28. So that is the S2 bar, S1 bar, S0 bar. So we write the all combination 000, 001, 010, 011, 100, 101, 110 and 111. You write the all combinations. So for 000, these all are the status signals. Okay. These signals are connected to the bus controller Intel 8288. Okay, the bus controller generates memory and IO access control signals. So 000 when the interrupt acknowledgement. Okay, interrupt acknowledgement. For 001, that is the read data from IO port. 010 write data into IO port. 011 halt, and 100 that is the opcode fetch, and then memory read, memory write, and last is inactive. So these are the functions. Accordingly the status will be decided. And after the lock bar, so lock bar pin number 29, it is an active low. It is an active low signal. When it is low, all interrupts are marked and no hold request is granted. Okay. In a multiprocessor system, all other processors informed by this signal that they should not ask the CPU for relinquishing the bus controller. What is the meaning of this? Meaning is that when lock bar is show the active low signal, and this signal processor sending this signal to other devices, that the processor now working its own operation. Okay, so no other devices can interrupt that 8086 microprocessor. Okay. After that, the request and grant 1 and request grant 0. Okay. So actually this is pin number 30 and 31, local bus priority control. Other processor ask the CPU through this line to release the local bus. After receiving the request, the CPU sends a request grant signal through the same line, indicating that the request has been granted and buses will be released after the end of the processor current bus cycle. So this the request and grant 0 is the highest priority than the request grant 1. You remember this? So these all are I have now I think that all of you understood the different pin functions for the minimum mode of 8086 microprocessor. Okay. Next class I will discuss the registers of Intel 8086. Okay, and after that I will discuss the internal architecture of 8086 microprocessor.